Now see, so what we have done, so current P is index is pointing at 1. Again, I is equal to P I made, nothing but I value is equal to right now it's 1. Again, what is the pivot element? That is 80. Okay, so top element is 80. Now see here, what are we going to do? We have J right now, nothing but, so what is that? J is equal to J plus 1. Yes or not? So that is what J is at pointing at 2. This is these things we have clarity about this one. So our previous example, we understood this one. Now see here, everybody observe here, what we will going to do? Same thing. So we have a pivot element 80. Again, we have 70 here. Now, what I will going to do? Compare this 70. That is what exactly I am telling you here. See here, everybody observe here. Compare this 70. A of j is what right now? It is 70. Yes or not? Less than or equal to what is the x value? Please here, what is the x value? 80. X value is 80. Now tell me 70 is less than 80. That is true or false? Actually, it's true. Yes or not? Actually, it's true. True means what we have to do? I is equal to I plus 1 we have to do, right? Again, we have to do the swapping. That is what exactly I will do. Now observe here. Now compare with 70 with 80. Okay. So I will going to compare. I will going to compare now. Okay. It says that 70 says that allow I am less compared to you. So that is the reason why J is telling that I am informing to you. Understood what I am saying is J saying that if J value is greater than 80, it will not inform. If J value is greater than 80, nothing but I, it will not inform. J value is less than 80, that is the reason why J is informing to I. Getting everyone? J is informing to I. That point you have to catch. J is less, that's why it is informing to 80. Nothing but P or I. Otherwise, it will not going to inform. Okay, otherwise it will move. Now, 70, okay, observe here, 70 is less than or equal to 80. This is actually true. So that's why what we have to do? I is equal to I plus 1, nothing but where I will come. You tell me where currently I is pointing here. I will come to here. Yes or not? I will come to here. Okay. Again, what is the I right now? Please here, what is the I right now here? Everybody observe what is the I right now? That is 70. So it will going to swap A of I and A of J. So what is the A of I value? 70. It will going to replace 70 only. That is the reason why I given this example. Anybody confused? See here, J said that very clearly. 70 is less compared to you. So that is the reason why. Okay, thank you very much. Okay, I will going to give you the value. J, don't worry, I will going to give you the value. So that's why I incremented. I came back to 2, index 2. Again, what it will done? It will going to give this value to this particular index only. That's it. Same number it will going to swap. Yes or not? I value it has to give it to the J, right? I value has to give it to the J. What is the where I came? I came to second index. What is the value I having? 70. Okay, it will going to be a swap that one. So that is what you are getting 70 here. Okay, now that is the reason why you people are getting 70 here. Clear? Everybody okay? Okay. Now see here. That's okay. After that, swap is over. J will going to increment here. Everybody see here? J will going to increment here. Again, J will say, hello, I am less compared to you. Again, I will going to increment here. I will going to come here. So what is the I value right now? 60. Yes or not? I value is 60. Swap. It will going to swap 60 only. Correct? Correct. Everybody okay? Okay, fine. Okay, now J value increments again, J value. As again, it will going to increment. Yes or not? Yes or not, guys? J value will going to increment again. J 100 less than 80. Yes or not? 100 less than 80. Okay, that's fine, no problem. J go 120 less than 80, no problem. Again go 130 less than 80, no problem. Okay, no problem. What is there? Yes or not? I is currently here only. I am I moving I? No, no. Am I moving I? No. J is but J is here. Again, J will come here. See here, everybody. J will come here. Okay, J value is what? Right now, 1. 1 is less than 80. What it will say? inform to I. J will going to inform to I saying that I am less. I will say, don't worry, I will going to increment the value. I am my value. Again, what is the value we have? 100. In place of 100, you will going to get the value 1. Yes or not? Here, what you will going to get? Here, you will going to get 100. Correct? Everybody correct? Okay, no problem. Again, that is also over. J I value came here. Again, J value increments here. J value is what is right now? 2. 2 is compared with 80. Yes or not? Now J is telling that I am less to I. I say that don't worry, I will increment. Okay. So now 120 will go here. It will 2 come here. 2, 120 will come here. Swapping. Clear? Clear everyone? Again, J will going to increment against here. 3 is less. Yes or not? I will going to increment. I will come here. It will say that give, I will take 3. I will give 130 to you. Correct? Everyone okay? After that's here. Again, J will going to be incremented. 200 compared with 80. What is that? 200 is greater. No swap, nothing. Because it's a false condition. Yes or not? Clear? I think you people got now. Yes or not, Manoj? You people got it or not? Correct? Okay. This is the procedure. Okay. Now, so that's what I told you. Now, please observe here. How many arrays we divided here? How many arrays we divided? See here totally. Totally, we have divided into T parts. This is one part. Pivot part. This is smaller part. Nothing but it is belongs to I part. This is smaller part. Nothing but this is belongs to greater part. This is belong to J part. Correct? This is a smaller one. This is greater. Understood how to divide, how to do the partition? This is the way to partition in the Quicksort. This is the way to partition in the Quicksort. Nicely explained. You can see this one. Nicely explained. Okay. Now what we got, what I told you very clearly. So where I is stopping? See here where I is stopping. Well, it is stopping at the last, at the index 6. This index and first index, you swap the elements. This index value and this index value, please swap the elements. Nothing but what? 3 will go here, 80. 3 will come here. Here in place of 3, 80 will come here. That's it. Okay. Now it indicates very clearly. It indicates very clearly I value. I value, that is the middle element. I value, there is a middle element for I and J. So here I will want to write here 80. Okay. Where exactly it is available? At the index 6. Okay, this side you write now. Left side, this side you write now, right side. Okay, now whatever the elements we have, write it. 3, correct? Here 70, 60, 1, 2. Okay, na? So that's it. Again, after 80, you write this 100, 120, 130, 200. Any doubts, Pa? Now you ask me if you have any doubts in this. Please tell me. If you have any doubts, please ask me. Okay.
Sir, I have one doubt, sir.
Ask ma, no problem.
Sir, what if an element is repeated in an array? Should we maintain the element or delete it, sir?
If it is repeated, no problem, nothing will going to happen. Why? Because the reason is telling you here I and J will going to compare. If it is greater, okay, it will not going to inform. Okay. So where actually if the elements, see what exactly you are asking, I got it. Suppose if the element is 10, 10. Yes or not? Correct, Nidhi? Yes or not? 10, 10.
Yes, sir. Yes.
So what it will do? Basically, it will come side by side. Yes or not? Side by side, you will going to get it. Apart from that, you will not going to get anything. If it is lesser to pivot element, what it will? It will swap. It will swap. Correct? Correct or not? Correct or not? Okay. That is what exactly it will going to
Yes.
happen. Okay. Nothing special in this. That is the reason why Quicksort is very clever. Quicksort is very clever. See how we got it. Nicely we got. So this side is completely smaller elements. This side is completely bigger elements. So pivot indicates that I am the middle. I am the middle. Yes or not? I am the middle. Now to sort this one, what do you have to do? See here, everybody. To sort this one, what do you have to do? One more time, please, one more time, apply the quicksort recursion. Okay, a comma, okay, 1 comma 5. Yes or not? 1 comma 5 again here. So nothing, why I'm writing 1 comma 5, you can ask me up to year. Okay, no need to go to year, up to year, up to year only, that's it. After that 7 to 10. Okay, that's why here quicksort. Why, you can ask me, sir, why? Already I written, right? That's why 1 to 5. No need to get confusion. So a 7 comma 10 already over, 6 is over. That's the reason why it says that, it says that already, it is clearly said that very clearly. What it is saying, that I am the middle for you both, I am the middle. It is saying that. Then what is the reason of writing all those things? Not required. Apply the recursion here again, you will going to get the middle element, like that it will be sorted. This is what we call it as quicksort. Okay, so what is the time complexity for this partition? It will take n, it will going to compare each and every element or not. That is the reason why, big O of n. That is the reason why big O of n. Okay na? Everybody okay now? So I think everybody got this one. Yes or not? Everybody got this procedure, partition procedure. I given the algorithm also, you can able to see. So this is the algorithm. Okay, this is the algorithm. So partition algorithm, this is the algorithm. Okay, this is what exactly we will going to swap here. Finally it will going to return the I value. That is what exactly we got it. So we got the I value or not? So that is what exactly middle element, pivot element. Okay, so that is done. I think everybody got this. Everybody got this. Now finally observe here. We will going to write a algorithm for quicksort. Now we are writing algorithm for quicksort. Observe here. Quicksort algo. Quicksort algorithm. Okay, na quicksort algorithm. Now everybody's here. So let's take an array. So that is what exactly you can able to see. We have taken array. So that is what you have to write like this. Okay, so that's what I am writing here. You can see now. So quicksort, okay, QS. Array A, starting index is P, ending index is Q. Okay, I think everybody okay with this. No problem, right? Now, okay, if here, if P value equal to Q, nothing but only one element. What exactly I'm talking about? If it is, there is a only one element. See here, suppose if I have only one element 80, so if I apply the quicksort, what it will become? 80 only. That is what sorted order, right? So that is the reason why I'm taking this one. What is that? If it is only one element, nothing but P value is equal to Q value, starting index as well as ending index, both are equal, nothing but sorted already. Okay, sorted. So that's why what it will going to return, nothing but only one element is there. If I apply the quicksort on this, what you will going to get it? Same element you will going to get it. So that is the reason why. What is that? A of P. Okay, so that is the first index. That's why A of P. That's it. Clear? Anybody have problem? No problem with this line, right? No problem with this. You will not going to get it because that much clarity is there here. Okay, go to the else part now. Else part. Else part means big problem. Else part is nothing but big problem. Now we did the partition or not? We understood how to do the partition, right? That is the reason why I said all these things. That is the reason why I said all these things. This algorithm, all these problems. I said that is the reason. This is the one reason. Okay. All these things I said because that is one reason how to do the partition. If I am able to do the partition, quicksort is bacha. It's easy. Okay. Now see here, everyone. Now what I am going to do? Partition. Okay, from where? A, starting index to ending index, we will going to do the partition. Now what it will going to return? It will going to return the middle or not? Nothing but pivot value. It will going to return the middle or not? That is what M. I will take it as M. Clear, everyone? Everyone okay? So that is what exactly we got it. After doing the partition, see here, after doing this array into three parts, We got the middle. We got the middle. Yes or not? I considered at the index 6, this is the middle element. So that is what exactly we got the m value. If I do the partition, you will going to get the m value. Okay, that's okay, fine. So this is the pivot element index. What do you mean by m is nothing but I will going to write here. M is equal to, okay, pivot element index pivot element index. M is nothing but pivot element index. That's what I showed you already. Now see here. So what I will going to do, that is okay. We got the middle elements here like this. We got the middle element. Yes or not? We got the middle element. This M value, we got it here. This is smaller. This is bigger. Again, I wanted to sort all these things. Means left side as well as right side. Means again, I have to apply the partition. Again, I have to apply the quick sort or not. Again, I have to apply the quick sort or not. So that is the reason why what I will going to do. Again, I will going to apply the quick sort. Again, I will going to get the middle element. Like that, we can able to sort each and everything. That is what exactly I am talking about here. That's why quick sort is equal to, okay, quick sort A, okay, P, up to where you will going to apply. See here, up to here M. Everybody observe here. See here, this one. Everybody observe here, from year to year. Okay, everybody, from year to year. This is, it indicates very clearly it is sorted or not. Up to year sorted. This is the reason why we got the middle element. It says that indexes is sorted. That's it, over. But what about this one? Is it sorted? No. 370, 60, 1, 2, not sorted. So that is the reason why P. So if I consider this one as M, what is this? Okay, P2, M minus 1. Yes or not? M minus 1. Yes or not? Yes or not? M minus 1. 6 minus 1. What you will going to get? 5. Up to 5. P2, 5. Yes or not? Clear? That is the reason why I will going to write here. I will going to write here. Okay. P M minus 1. Why I am writing M minus 1? Understood? That is what? So 1, 2, 3, 4, 5. Up to 5. Nothing but 6 minus 1. It will become 5. That's why M minus 1. That is okay. This side is okay. This side also I have to apply right. Fixed. This side also I apply right. Fixed. That is the reason why. One more recursion you have to apply. That's why fixed. Here array A array A. From this side we have to do right. That's why M plus 1. From here M plus 1. So that's why see here everybody, M plus 1. Again up to where? P. Sorry, Q. Not P. Up to Q. Okay, na? So this is what exactly you have to do. This is what exactly you have to do. Again, finally. So what it will going to return? If you do all middle elements, you will going to get like that, like that. Everything will be sorted like this. Everything will be sorted like this. Finally, what it will going to return? It will going to return the sorted array. So that is what exactly. Okay, na? Clear? So this is your algo. This here, this is your algo. This is your algo. Anybody have problem? Anyone have problem? Please tell me, anyone have problem in this? No, I don't think so. You will not have a problem. Now see here, everybody observe here. So this is a function, yes or not? Let me take time complexity for this particular input function. What is that? T of n. Okay, can I take like this? T of n. It is an input function array. Starting index, again last index. Yes or not? Input function. Again, how much time it will going to take to execute? This one, everybody observe here. How much time? It will take constant time. Yes or not? Big O of 1. Okay, now see here, come to the else part here. This is a big problem. So partition, how much time it is required? Because all the comparisons I have to do here. See here, all the comparisons I have to do here. That is the reason why n or not. For this one, it will take big O of n. Yes or not? Okay. Again, come back here. This one here. So how much time it will going to take to execute? So that is what? T of m minus p. Sir, you can ask me, sir, how you got this one? Please say how you got this one. Very simple. In array, you do like this. M minus 1, that is what exactly here. M minus 1 last. Yes or not? M minus 1, okay, minus p plus 1. P means nothing but here first. Yes or not? If it is P, if it is Q, basically this is M here is there, minus 1 means up to here it will come. That's the reason why I wrote m minus 1. Okay, na minus p, nothing but first. So this is what is that? Last, first. Okay, last, first plus 1. That's it. Okay, clear? Everybody clear now? Everybody clear? So minus 1 as well as plus 1 cancels. What you will going to get it finally? M minus p. That is what total. Okay, na? Everybody okay? Okay, now see here again, this one here. Basically, you can every time what I'm writing, actually every time I'm writing n by 2. Yes or not? N by 2. Why? Because it will be divided into two parts. But you tell me, am I doing blindly here? Not at all. That is the reason why sometimes you will going to get more in left side, sometimes you will going to get less. So that is the reason why not m by 2 here, not n by 2, not at all possible. Not at all possible. Don't go like that. Okay, don't go like that. That is the reason why I'm writing this one. M minus p. Okay, here also same thing. T of q minus m. This one also I will show you how I got it. See here, everyone. So what is that? Basically, q, here I will write q minus nothing but this is the last. Yes or not? Last one is nothing but what here? This is q. Okay, minus. Okay, first, what is that plus here? M plus 1, right? M plus 1. Okay, plus 1. Clear, everyone? Everyone okay? What it will become? Q minus m minus 1 plus 1. Minus 1 plus 1 cancels. What you will going to get it? Q minus m. That's it. So that is the reason why here q minus m. Over. Everybody over. Understood? It's clear. It's pakka clear. Okay. So this is what exactly you have to understand here. Please observe here. Okay. So this is your recursion time you people are getting here. Okay. Let's move further. Let's move further. I think you people got it. Let's write the time complexity for this. Again, we will going to finish it. No problem. That's it. Very simple one. Okay, we will going to finish the time complexity. That's it. Over. Still more is there. If you want it, I will going to tell you, but not required. Actually, those things are not required. This is more than enough. That is little bit advanced. Okay. Now we will go to the next slide. Now see here. Take this, everybody. Let Tn is equal to time complexity of that algo. Okay, so what we'll say that above algo, you can say above algo. Okay, because it's backside. Okay, so I will say above algo on n elements array. Now what we're going to do, suppose t of n, this is the function, right? T of n is equal to, now see everyone, if n is equal to 1, that's what I told you. If it is only one element, what is that? Constant. We know that very clearly. Now see here, everybody go here. See here, we got this one function, we got that one. This one you see, don't worry about this one because it's a constant. Okay, no need to worry, leave it. Already over. This is over already. Yes or not? This is already over, finished. Now see here, partition you can see. So what is this exactly? Partition is nothing but divide. Partition is nothing but divide or not? I told you partition is nothing but divide. Okay, and this one, what is that? Recursion. Again this one, recursion. Fine. So now go to this one here, right here. n plus, okay, t of m minus p. You know why I'm writing m minus p, already explained. T of again q minus m. When, if n value, number of inputs is greater than 1, then only you will going to get this equation. Correct or not? Then only you will going to get this equation. After that, see here in this, after that, okay. So this is n is nothing but what? Basically divide. N is nothing but what? Divide. Okay. Partition, division. Okay, that is what I'm showing here. Now in this, see, there are two cases you will going to get this. One is best case as well as average case here. Again, worst case here. I will show you that. Best case and average case I will going to show here, as well as worst case I will going to show here. Everybody observe here. Now let's take T of n. So that is equal to n, okay, plus T of n by 2. Suppose if it is like that, okay, if you divide it, whatever the if you do the division, if you got the element at the exact middle, that time what I will going to do, n by 2, 2 n by 2 n by 2. So finally what you will going to get it, 2 t n by 2 plus n. Yes or not? Just I'm saying the best case as well as worst case. Okay, best case, average case I'm telling you. Suppose nothing but that is what exactly, if the elements is there, if your m value is coming exactly at middle, this side n by 2, this side n by 2, like that, if you got it, means that time I'm saying that what is the best case. That time I'm saying that what is the best case. You divided, you got the value n by 2 n by 2. That time I'm saying that what is the best case here. So apply for n times, log n times, log n times you apply. Okay, finally you will going to get it. What you will going to get it, you will going to get time complexity is equal to, basically already I did this one, that is the reason directly I'm writing big O of log n. That's it, big O of n log n, sorry, n log n. Okay, so this is your time complexity for best case as well as average case. Okay, fine. Again, worst case, everybody observe here. Again, for worst case, suppose think like that, T of n, okay. Wait. T of n is equal to, okay, divide n plus T of n minus 1. Suppose only one element is there, okay, there is no element. Consider right, left side elements are there but right side is not there, okay, nothing but zero elements. That time T of 0, okay, nothing but it is empty. Yes or not? Now what happens here, n plus T of n minus 1, okay, T of n minus 1, what it indicates, what it indicates very clearly, n like that it will go or not, n minus 1, n minus 2, n minus 3, like that. Okay, so what you will going to get it, you will going to get the natural numbers, right? 1 plus 2 plus 3 plus, okay, up to n. Yes or not? Up to n you will going to get it. It indicates what is that, sum of natural numbers or not, this one, sum of natural number or not. So that is the reason why n into n plus 1 divided by 2, nothing but totally what you will going to get it, basically. So totally you will going to get it big O of n square. Okay, big O of n square. This is the worst case. This is the worst case. For that also I will tell you. For this also I will tell you. See here, if you want it, uh, see all these elements. If all the elements, whatever the elements are there, if it is divided into two parts, nothing but equally divided, n by 2, n by 2. That is what I showed you. If it all the elements which are come to this side, okay, all the elements, Nidhi asked good question actually. That's what exactly. If you have taken the elements similar, if all the elements into come to this side, what about this side? We are not at all applying the recursion. That is the reason no need to go that side. So that time it will come this side. Nothing but irregularities is there here. Irregularities. So that is the reason why what happens, time complexity will going to be increased. Okay, time complexity will going to be increased. For that also I will show you. Don't worry. See. So I can point you one thing very clearly. Most of the time, quick sort. Okay, give the balance time. Why? Because it will going to divide the elements in a equal way. So that is the reason why. Never think like that. You people never think like that. You will not going to get like this. Here zero elements. Here all the elements like that. You will never going to get it. Very rare case. This will going to happen. Very rare case. That is the reason why quick sort is very clever sort. Okay, very clever sort actually. All the time it will be balanced. For example, you take it as a element like this. Okay, just consider element like this. Consider an element that will be divided like this. Okay, balanced tree like that. Here also elements array. Again that will be divided like this. That will be divided like this, like this, like this, like this. Okay, so here n, here also n elements, here also n elements, like this follows. Okay, nothing but what happens, your time complexity will be n log n or not, n log n. Your time complexity will be n log n. But In another case, worst case, suppose all the elements had come at the left side. What about right side? No elements. What happens? The tree will goes like this, like this. After that, like this. After that, like this. Nothing but so much irregularities. Yes or not? First, initially n minus 1, again n minus 2, n minus 3, n minus, like that it will goes on or not? 2, 1, like that it will goes on or not? So what happens here exactly? Okay. So sum of natural number, basically we're going to get n square. So that is the problem. That is the problem. But almost all, most of the time, I'm telling you, most of the time, it will be balanced. Okay, it will be balanced. Don't worry. Okay, most of the time, Quicksort will give you the balanced time. So like this, almost balanced time only we're going to get it. No need to worry. So this is completely all about what is that? This is completely all about what is that? Quicksort. Okay, this is completely all about Quicksort. Okay, fine. So please go through all this, everything I explained neatly. Okay, just go through all these things, you will get everything. Okay, nice. Thank you.